Hello and welcome. Today I'll be taking you through a short presentation on Splunk ITSI and its main components. The presentation will then be followed by a demonstration. To begin with, what is Splunk ITSI? Simply put, ITSI is a software tool developed by Splunk that uses artificial intelligence and machine learning to help monitor increasingly complex computing environments. So let's get stuck into the key components. First, we have glass tables. These provide a simple representation of the current health of your service and its dependencies. ITSI's glass tables enables a clear view of the most important metrics, from operations to marketing to business executives. It can also allow you to navigate to deep dives, dashboards, or even custom URLs. Our next key component is the Service Analyzer. The Service Analyzer screen monitors all key services and service elements, either using the tile view or tree view, showing a health score and trend graph for each. This can be used to triage the most urgent issues that require attention. Next, we have adaptive thresholds. Adaptive thresholding in ITSI uses machine learning techniques to analyze historic data and determine what key performance indicators, or as they're more commonly known, KPIs, behaviour should be considered normal in your environment. This can be both simple and complex. Our fourth key component is anomaly detection. Anomaly detection uses machine learning algorithms to model KPI behaviour and generate alerts when a KPI deviates from an expected pattern. If the KPI diverges from the normal pattern, ITSI creates a notable event in the episode review. Our final key component is predictive analytics. Predictive analytics uses machine learning algorithms to predict the health score value of a selected service in ITSI. The models use historic service health scores and KPI data to approximate what a service's health might look like in 30 minutes. We will demonstrate this later on. Adaptive thresholds and anomaly detection. Adaptive thresholding works by analysing historic data using machine learning to determine what should be considered normal. In Splunk, the training data can span over the last 7, 14, 30 or 60 days. Since the shape of the data can vary dramatically, Splunk supports adaptive thresholding based on standard deviation, quantile and range. The adaptive thresholding automatically recalculates at midnight each day to ensure that slow changes in KPI behaviour doesn't trigger false events. Although ITSI supports static thresholds which can be used for individual entities, adaptive thresholding allows you to train data and configure it for the entire KPI. This is more of a broad brush approach. Or you could set the thresholding per day or even per hour, which allows you to have more precise alerting and less false positives. For example, here we have a standard default threshold using standard deviation applied to the data. However, if we wish to add a specific day with specific thresholds, then the preview will look something like this. And lastly, shown on the screen is a more granular approach, with every day and every hour shown with adaptive thresholding applied. Moving on to anomaly detection and predictive analytics. Anomaly detection in ITSI uses machine learning algorithms to model KPI behaviour and in turn generate alerts when a KPI deviates from the normal pattern. For example, if you have transactions streaming through a payment system and every Monday the volume spikes at 50,000 transactions, then this would be the expected behaviour. Similarly, if the same spike happens on a 4-weekly basis, again this would be learned and expected behaviour. However, if the spike appears on a Tuesday, then this would be deemed as an anomaly and an alert would be raised for further investigation. Anomaly detection is further enhanced by predictive analytics. Predictive analytics uses machine learning algorithms to predict the future health score of your service. You can train and test different machine learning algorithms to determine which one will give the most accurate predictions. It does this by looking at patterns of behaviour over time and based on experience and lateral conditions that have previously led to adverse events or service failures. These actionable events can be used as a catalyst for investigating and preventative action. Over time, operation teams can move from a proactive to predictive state, whereby adverse events can be detected and corrected before they have the opportunity to affect live services. For example, here we have the predicted health score of the service in 30 minutes, as well as the worst case predicted health score in 30 minutes. This can allow a support team time to start to investigate. So now that we've covered some of the background information, it is clear to see the benefits of Splunk ITSI. A successful implementation of ITSI has been shown to reduce unplanned downtime by up to 60%. I'd now like to pass you on to see a demo of everything put together. Thank you.
This will be an 8 to 10 minute demonstration covering existing dashboards versus ITSI, adaptive thresholds, predictive analytics, and glass tables. We'll start with the Splunk Enterprise dashboards. This was the initial request from the client to ensure a like-for-like with the outgoing payments monitoring system. The initial landing page details the status of each service based on KPIs requested by the client. Here you can drill into the services. For example, take the inbound payments as shown on screen now. Here you can see the volumes being processed. The white line shows today's volumes, and the different colours show the comparison against the previous 7-day average per 5 minutes with a standard deviation. Although this is a good indication to identify spikes and inconsistencies in their data, additional searches and alerts are required for any spikes that occur to determine whether they were accurately reported or not. There was no further way to predict what would happen with future payments, making it very much a reactive scenario rather than predictive. These thresholds had to be developed and manually calculated here. Therefore, there wasn't an adaptive element to the charts. This method also doesn't consider any anomalies or inconsistencies that could lead to false alerting. Although this met the Phase 1 request, Phase 2 was to move to ITSI, utilising glass tables, the service analyzer, adaptive thresholds, as well as machine learning to predict service health. We will start with the glass table before focusing on the adaptive thresholding and predictive analytics. The ITSI glass tables for payments enabled us to clearly communicate the service health of the individual payment services and infrastructure. The service health is based on a 0 to 100 scale, with 0 being critical and 100 being normal. The overall payments health is an aggregate of all services health combined. From an operations perspective, we can now determine what is impacting the payment service from the infrastructure. The tree view shows the links. In this example, we have configured an infrastructure layer that links to each of the payment services. If any of the infrastructure services start to degrade, this will impact on the health of the payment services. Although we have linked each payment service directly to the infrastructure layer, you can adopt a more granular approach and have individual servers linked to individual services. Furthermore, you have the ability to drill down to the individual server or appliance and view any alerts, known as episodes in ITSI. As covered in the presentation, adaptive thresholds work by analysing historic data to determine what should be considered normal and what the high and low bounds should be against the normal. To demonstrate the adaptive thresholding feature of ITSI, we've configured two separate services, one with a full week per hour per day to reflect the client's requirements as per the original dashboards, and the other for a Monday only. So let's start with the Monday only service. Here we have the store and forward service. We have entered the basic search that we need, set the backfill to 7 days, and configured both adaptive thresholding and KPI alerting. For the alerting, we have set a trigger for when the severity changes. For the adaptive thresholding, we've used a standard deviation and selected the tolerances for the deviation away from the overall average. This is where the human input comes to train the data and configure a more accurate business profile based on machine learning. Setting the default will apply to all days and hours, however specifying a day and hour will allow a separate threshold. Then applying it using the adaptive threshold will calculate the threshold values based on the previous 7 days. Each day at midnight, this will be updated and recalculated. If we want a more granular approach, we could configure the service per hour per day. For example, here we have the inbound payments, and unlike the store and forward, we want to have the thresholds for each day and hour of that day, as well as using a standard deviation template that can be applied to the rest of the services if required. As can be seen, we have a consistent pattern of data with a few peaks on a Friday, but still within the acceptable limits. The thresholds will be bigger when you have noisier data, so on a weekend you would have the thresholds closer to the black line than on Monday. If, however, you have data that may spike on a Monday once a month and then is normal for the rest of that month, you could also use anomaly detection to first analyze the data over a 60-day window and identify if the data departs dramatically from its typical pattern. Predictive analytics uses machine learning algorithms to predict the health score value of a selected service in ITSI. The models use historical service health score and KPI data to approximate what a service's health might look like in 30 minutes. Take for example the inbound payments. Here we want to determine the health in the next 30 minutes. To do this, I've selected the last 7 days, the regression algorithm, and then linear regression to create and train the model. Now I can see what my average case and worst case service health scores will be, allowing for investigation before there is an issue. The worst case is the lowest predicted health score within that time window. The R-squared number tells us how well the model approximates to the data points, and the closer to 1, the more accurate the prediction. The RMSE is the average difference between the predicted model and the actual model. In this case, a smaller number is better. All of these models can be saved and viewed at a later date in the Predictive Analytics Dashboards tab or in your own created dashboard. Lastly, if you want to see the data in standard Splunk dashboards, then there is an app available on Splunk base that allows data to be pulled from ITSI indexes and displayed using standard dashboards. So in the inbound payments example here, we can see the adaptive thresholds applied to the inbound volume. Recovery managers can have standard Splunk-type dashboards and glass tables, whereas analysts can see additional specific detail using more features of ITSI. If you have any questions about this demonstration, please feel free to contact ECS. Thank you.